Ladies and gentlemen, good morning.
Good morning.
As someone who was born and live in Taiwan, I would also like to welcome all of you to attend this meeting. But I might disappoint you. I'm not talking about cuisine. I was asked to be the master chef. We'll talk about my experiences and relate to the innovation rather than cooking. Because I belong to those people who believe, like German said, Hunger macht the beste Koch. Hungry makes the best cook. So you go to the restaurant, whether it's an excellent food or not. I do appreciate food very much, excellent food very much, but that depends on how hungry I am. And I'm always hungry, working very hard and came back late. So my wife's cooking is the best in the world. Well, today I used the title and said, Dare to be different. Actually, I was born in 1936. It's a long, long time ago. I've come close. When I entered the elementary school, the Second World War was coming to an end. And at that time, B-29 is a beautiful airplane, except the bombs. Was bombing Taiwan on a daily basis, and school dismissed. And there's no more school. We all ran into the mountain. And that was the wonderful thing happened to me. Not the bombing, but school is closed. So I went to the mountain, lived almost for 2 years. And I would say that's the best 2 years in my life. I learned a lot without having to attend the classes. I learned from the nature, the change of the season, how things grows, and learn farming from the farmers and catch some fish, food. And that 2 years is really the best 2 years in my life. And I always believe that when someone was growing up, we should take them away from the city and put in the nature, learn from the nature. That should be a wonderful, wonderful thing. But unfortunately, it's only lasted for 2 years. War came to an end from mountain. So you can see the beautiful mountain, and we have to come back to the city. And when I came back to the city, attended school, I did have all sorts of things open up in my life, like playing baseball. I was an avid baseball player when I was young, and actually last week I was in New York, and the New York Mets had a Taiwan Heritage Day and asked me to throw the first pitch. So I flew out to New York and threw the first pitch. And that was a strike. And then I came back to Taiwan. But actually, now they start a new thing like playing baseball. I started to try to understand what's going on around the world, and reading some of the books, and a cartoon really attracted my attention. It said, a lamb came into the laboratory and asked the scientist, "Can you change my wool to nylon?" Well, that was something which was quite exciting to me because I really enjoy nature, learn so much from nature. Yet, a lamb came and asked scientists to change the wool to nylon. After the Second World War, as you may know, the nylon stocking was really one of the most exciting things for ladies. It's strong, so thin, and not very easily broken. And so when Lam said, "Can you change my wool to nylon?" I started to respect scientists and science. Science can do wonders. In spite of the fact you learn so much from the nature, you like nature, but scientists can do sometimes can do better than nature. And so I started to get interested in science a lot. And at the time, I also liked music. I joined the brass band and playing music all the time. I was an avid reader, reading books, trying to understand the changing world. During the war, I didn't understand why people used to fight. After the war, you see the changes, revolution in China and independence of creation of the nation of Israel, and Palestinian people were driven away. There are so many things I really try to understand. And among the books I read, I was most interested in the book of Madame Curie, written by her daughter, because in that book, I can see how beautiful the life of a scientist could be, and also see the extraordinary patience, determination, and curiosity. She believed that radioactivity is coming from atom, the decay of atom. At that time, nobody believed that atom would decay or change, but her unwavering belief in the hypothesis of radioactivity as an atomic property and her spirit of adventure and readiness to pursue unorthodox thinking were most impressive. And the other thing is excitement of scientific discovery and her idealistic way of life. She certainly influenced me a lot. So by the time I finished 9th grade, I was quite determined to become a scientist, become a chemist. And she did play a big role of it. But when I was entering the 10th grade, I was playing sports, baseball, ping pong, tennis, and also in the brass band, choir, and doing some artistic work. And I was very busy, and I was avid reader, read until midnight. And biology teachers asked me to make some cutout view of the fish, of the ear, and so always woke until 2 o'clock in the morning, woke up before 7, and I got too tired. And one day, I could not go on. And doctor said, you should stay home for at least a month to recover from your exhaustion. So I did stay at home. And that was the time which is the second turning point of my life. I sit there, I sit at home. Wasn't really sick, I just exhausted. So didn't go to school. And the first time I didn't go to school was because of the bombing. Second time I didn't go to school was that I was exhausted. So I stayed home and thinking like a philosopher. I was thinking every day about why we are here, what's the meaning of life. And because I was an avid reader, I read lots of things like Mahatma Gandhi's biography and scientific books. And at that time, one thing really came to my mind. I have to wake up. I would wake up. Although everybody believes we are born to be free, you are born to be an independent person. But actually, if you examine your life, it was not quite true. We are captivated, partly because of the value judgment of your parents, or the society, or cultural heritage, or other things. You're really captivated and move, and you play baseball, want to win, and play music, brass band, and busy going in life. But is that really what you want to do? And when you become 80, I'm already past 80, you sit down and think about what you have gone through in your life. You follow the uniformity, and you form all the way what other people believe one should do. And that time I was waking up. The first thing I said, escape from the captivity. I want to become the master of yourself, not the master of within. Master of yourself and lead a meaningful life. So I didn't go to school, and then school doesn't mean as much to me anymore. I want to learn, I go to school to learn, but what I learn and what school is going to teach me is entirely independent thing. So at that time, I already decided I want to pursue a career of an outstanding scientist and also want to working together with idealistic people for an equitable and democratic world. So when I finished my high school and entered the National Taiwan University, I really have two goals in mind. Very simple. Want to be a good chemist, a good scientist, and want to work with idealistic people to make this world a better place to be. And so when I entered the university, I started asking myself some question and doubt in the freshman year in the university. The question was, if I take all the courses over in the department of chemistry and study well, am I going to be a good chemist? That's an important question, because you're going to work very hard in the university. Am I going to be a good chemist? The answer was no. Talking to many senior students, and they gave us lots of discussion, they said no. I said, why no? Because in chemistry department, we learn a lot about the structure of matter, chemical bonding, how a chemical compound transform, how can you synthesize new compound. But at the beginning of the 20th century, scientists already started to understand the law of nature govern all microscopic particles. And chemistry department will not teach any of those. Chemistry department will not teach electricity, magnetism. Chemistry department will not teach this and that. And I realized, even if I study hard, I will not become a good chemist. So I mapped out my career and said, I should learn this. So organize a study group with students and spend evening times and study very hard. So I study all the things I believe, or everybody believe, one should learn when you want to become a good chemist. So, from a very passive student taking courses, attending the lectures, to a very active person who wants to learn something and do something, it was entirely different. So by the time I was a university student, I pay attention to interact with professors, that discuss some matters, but I really don't care what classes are taught and how much school are teaching me. And at the time, I really learned many things, even include Ruski Yazek, Russian. At the time in College of Science, learning German. I learned Japanese when I was young. So I really tried to do what I thought one should learn. So in Taiwan, I took courses, studied all of those, and also did some research. Actually, I did three kinds of research when I was in university and graduate school. I first worked on the paper electrochromatography and separating barium and strontium in a very quick way. And at that time, started to use non-aqueous solution and do some separation quite successfully. Later on, I did work on the radioisotope in a mineral called octolite. Octo mineral is a unique mineral in the world. And then later on, I studied X-ray diffraction. So in Taiwan, I was quite well prepared as a graduate student, finishing my master's degree. Then I decided to go abroad to study for my PhD program. And at the time, I did learn German. So I wanted to go to Germany, but my girlfriend, my fiancée at the time, she learned French. She didn't want to go to Germany. So we decided, okay, we go to America. So we went to the United States. So we learned quite a bit about America and look at the movie, those American propaganda movie, and said nothing is impossible in America and very crazy things going on. And I was also studying many books, and one of the books which really excited me It's we the people. And actually I read the Japanese translation of Leo Huberman's book and described America as a democratic society. When in Transforce gathering, a representative walked in and said, shoved the people aside and said, I'm the representative of the people. And people got very angry and said, we are the people. You are just the representative of the people. And I was excited that the United States people is really the master of the country. And apply for many universities. One of the universities gave me the fellowship, the first very lucrative fellowship, and said, I didn't have to teach, give you fellowship, why don't you come to Chicago? And I remember a couple months ago, I was watching a movie about El Capone, about gangsters slaughtering in Chicago. I said, no, Chicago is not the city I will go. Chicago certainly will not be. Then I decided to go to Berkeley, a beautiful campus, beautiful city, especially in the afternoon when the folk moving in from San Francisco. You really believe you are in heaven, and really wonderful. I didn't mean that I passed away already in heaven, but it's a really wonderful place, a good place for study science, and that was the time. Free speech movement was really going on in Berkeley. Students start to re-examine the way of life and also how the society has been developing. They have lots of questions. And Mario Savio was speaking at the time, and I often went to the rally and watch what they're doing. And John Bayet would come and sing the folk song during the lunch break. And when they started to occupy the administration building, they asked the questions, every foreign student should step out, otherwise you will be deported and when you are arrested. And that was exciting time. Exciting time because in the free speech movement and the Vietnam War, anti-Vietnam War movement, students really started to think themselves and the society as a whole. And at the same time, I chose a research advisor to start the research. I worked with Professor Mahan. He was quite interested. We discussed and said, well, okay, you're interested in some of the chemionization process, so why don't you use it as a PhD program? So I decided to work on the photoionization, chemical ionization, chemical reaction produce ions. And when I went into his office and said, Professor Mann, how should I start? He was smiling and said, Yenze, that's your PhD program. I do not know the answer. If I know how to do it, I would have done it a long time ago. So it's your program. I went home and talked to, at that time, I was married to my wife, and talked to my wife. I might have made the wrong decision. I came to a place and talked to professor. He said, I don't know how to do it, and it's your problem, and I have to do it. Well, I came back to talk to him many times and said, Professor Mahan, and he said, don't call me Professor Mahan, call me Bruce. Well, that was not easy for me. Somebody from Asia respect professor so much and call his first name. But after 3 months, first time I said Bruce, he was smiling, and so this kid might be hopeful. But the interesting thing is when I went into the lab and he came to see me, he always asked me, what's new? So I told him what's new, what I'm doing, I have been doing. The next question is, what are you going to do next? So I said, I plan to do this. Very often he nodded his head. It was a many comment, and he went away. Every day he would do that. He would come to the lab and say, what's new? What are you going to do next? Well, about 2 years going on the way it has been, Then I found out that every time when he came to my lab, I behaved like a professor teaching a student and said, I've been doing this, and I'm going to do this. And so I told my wife that something wrong. I came to the States and a famous university and talked with somebody who doesn't know too much and said, that's your problem, and I have to tell him what I've been doing, what am I going to do. And after 2 years, one day he came and said, Yuan, you've done enough. You should start right after thesis and finish your PhDs. I was furious. I said, Bruce, I came to the States, I really wanted to learn something. You came every day and asked me, what's new? What are you going to do next? And after 2 years, you're going to kick me out. I said, no, I'm not going to be kicked out. And Bruce said, you are really doing well. You've done well, not only done well, you know what to do next. And so that's all what we take to have a good scientist trained the way. So I did start to write the thesis. At that time, he said, if you want to stay longer, it's okay. You can stay as a postdoctoral fellow. You can do whatever you want. But help me take care of some of the graduate students in the laboratory. I said, fine. When they say you can do whatever you want, I was excited. I can do whatever I want to do. And that will not happen in Taiwan. As somebody who finished PhD and said, you can do whatever you want. So I told Bruce that at that time, Professor Hirschbach's group was doing scattering of alkali atom with other molecules and measuring angular velocity distribution to understand the chemical dynamics. But experiment was very primitive. Velocity was not chosen. Final velocity was not analyzed. But I said, I would like to do ion molecule reaction. Use ions, I can control the velocity, and I can analyze the energy. And Bruce said, fine, you want to do that? That's fine. So I did spend almost a year, learn to construct the machine, and at that time we didn't have computers. So try to analyze when ion molecule collide, and I want to analyze energy. We have an energy analyzer, transport the ions through my spectrometer, so do the particle counting one by one. And this is really another turning point in my life. I did learn to do experiment, talking to engineers and other scientists. When I started, a mechanical engineer came every day and tried to help me to draw the mechanical drawing. What is the welding sequences, how every screw hole to be drilled, how precisely, with what kind of drill bit, and tape at what size, and how precisely hole has to be located. Taught me all the things, which this process was too slow. If I follow what he has been doing, what we've been doing, it might be taking 3 years to finish this job. I said, no, I have to finish in 1 year. So he spent a week, taught me how to do mechanical drawing. From that time on, he lost the job because I do it everything myself, and mechanical engineer was kicked out from my lab. So it spent a year. I did construct the machine. That was 1967, almost half a century ago. That machine was quite complicated, but we have an ion produced, go through the magnetic mass spectrometer that was designed by myself, scatter through the other molecule, go through the energy analyzer, doing particle counting one by one. And that was quite successful. Professor Ben came back from sabbatical. He was really amazed to see that I can take the N2 plus ion, set it with hydrogen molecule, and measure angular and velocity distribution. And I understood, in fact, what's going on here. What's going on here is really N2 plus ion come close to a hydrogen molecule. Hydrogen atom transfer first, and then N2H scatter from the hydrogen atom to come up with this angular velocity distribution. So this is an interesting process, chemical reaction taking place, electron transfer, atom transfer, then the collision was between N2H++ hydrogen atoms. And that was the first time chemical reaction was studied in such a detail. In the springtime, when I was doing this, Professor Hirschbach came through. He was a professor at the UC Berkeley. I took his course in 1963, quantum mechanics course from him. He was attracted by Harvard University and became a full professor at Harvard University. He saw my data and said, wow, that's a dream, what we want to accomplish, but we have to do it on the neutral molecule. Like doing combustion process, atmospheric chemistry. Ion is nice, but really want to do neutral. So I went to Boston in the spring of 1967. It was during the blizzard. And when I went there, Professor Hirschbach said, Yuan, you really need to do neutral molecule scattering process and measure the angular velocity distribution of product. Around that time, there are about 10 groups in 1967. There are 10 groups of people all over the world trying to do atom-atom scattering and measure angular and velocity distribution. And we want to go beyond, not only this elastic scattering, we want to do the reactive scattering, but nobody was successful. The 10 group, they're doing it. Nobody was successful. And when Dr. Hirschbach asked me that, Yuan, you should be able to do it. We should be able to overcome the problem and solve this problem. At that time, people had some misunderstandings. All 10 groups believed that the reason they were not successful was because the detection sensitivity was not good enough. If you have ion coming in, you can do particle counting one by one. Neutral molecule, you have to ionize it first, accelerate it, and then could be detected. Efficiency is 1 part of 10,000. So, Dick Bernstein wrote the review in 1970. He said, problem of the detection of neutral particle present the most serious limitation to the molecular beam scattering technique, except for experiment with alkali system, for which surface ionization detectors of nearly 100% efficiency exist, even with the use of modern high-intensity neutral beam source. General neutral scattering experiments have not yet approached the sophistication of analogous studies involving charged particles where direct counting is possible. Actually, that was the one I've done, the charged particles. But that conclusion was not right. If you are in the cities, try to look at stars. You cannot see stars because there are lots of light emitted from the buildings. And so if you want to look at the star, what do? You improve the sensitivity. You improve the sensitivity 100 times, 1,000 times. It's not going to help you. The best way to do it is to ask electric power company to turn on the light, turn on the electricity, then all city become dark. Then you can see the stars. But people are not doing the right thing. They cannot see the stars. So they try to improve the sensitivity. You can see more and more. And certainly you cannot see it. After I found out that everybody was doing wrong, we did build a machine. We did build a machine to get rid of the actual light, just like turn off the electricity. So although molecules scatter only 1 part of 10,000 and scatter a certain angle, go through the ionizer, ionize, and then go through mass spectrometer, then do particle counting one by one. We are quite successful. 1 year later, we finished this machine, and started to do the experiment. But during the time I was doing postdoctoral research, many famous scientists passed through. And Harvard University was famous, Department of Chemistry. There are so many visitors. One of the scientists from Caltech, he was doing cross beam experiment for about 10 years without success. When he saw me doing mechanical drawing, he said, "Yuan, what are you doing?" I said, "I want to build a machine to do scattering of neutral molecules." And he looked at me and said, "You want to finish it in 1 year? You must be joking. I've been working for 10 years with a group of people and started to understand, started to have a feeling how to do it right." I didn't dare to tell him that you are doing all wrong. During the last 10 years, you're doing all wrong. And you want to do it right? You want to see the star? You have to turn off the power. You have to turn off the power, and then you do it. Just like the way I was doing. And I was not going to do detail. But this apparatus was good enough to look at the reaction, like fluorine atom and deuterium molecule, and look at the scattered molecule, how fast it moves, in what vibrational state molecule are in. And then we will understand that from this angular distribution, you know the molecules should line up together. At the same time, energy released to forming deuterium fluoride, or in the vibrational. You can operate the chemical laser and powerful enough to shoot down the airplane. And this chemical reaction could be a pumping reaction mechanism for chemical laser operation. And that was the thing we've been working on the elementary chemical processes. And because of the contribution we made in that area, I received a Nobel Prize with my boss, Dr. Hirschbach, and another Canadian scientist doing chemiluminescence experiment, and John Polanyi. And it was interesting. I was invited many times to go to give lectures, so all over the world. Once I got a phone call from Milano, mayor's office, and said, "Professor Lee, Milano is celebrating the city for science and technology. Could you come to give us a lecture?" I said, "Fine, I'll be happy to do it." It will be next month. I bought the airline ticket, arrived in Milan early in the morning. They took me into the lecture room, and just like this, with many audience. And I just came up from the airplane, a little bit shaky, but he said, "Professor Lee, you have to answer some questions before you give your lecture." And he started asking me cuisine, lots of things about cuisine. And I said, wait a minute. Why are you asking me those questions? Would you show me the program? And when I read the program, I was shocked. And Professor Lee, he's an expert in elementary chemistry. It's elementary chemical processes I win the Nobel Prize, not elementary chemistry. But they made a mistake, and when mayor's office translated the English in Italian, so elementary changed to elementary. And who chemist, elementary chemist, maybe just like today, was sitting there and expect me to talk about elementary chemistry. I was talking about chemical dynamics, and then he said, "Professor Lee, your slides are beautiful, but I do not know what you are talking about." But the evening, when the mayor of the city threw the party, that was really excellent elementary chemistry. It was really excellent food. But I was in a very different situation, but this cuisine lecture reminded me of that story. And actually, I studied a large fraction of my time, study chemistry related to combustions. The reason is combustion of fossil fuel provided most energy you need for the development of human society. Like methane react with O2 will form CO2 plus water molecule. And actually molecular collision induces chemical change. But want to remind high school students as a collision between oxygen and methane would not produce carbon dioxide. It's really quite complicated. Quite complicated. You have to initiate. So one of the methane one will break and from radicals, and the step by step, and then the final product could be carbon dioxide with water. So I was trying to investigate every elementary processes, or the elementary processes, cooking up to form carbon dioxide and water molecules. At the time, we were a little worried about production of carbon dioxide because Arrhenius, in the early part of the last century, he did mention if we keep on burning the fossil fuel, the accumulation of carbon dioxide could warm up to grow. Arrhenius was in Sweden. He thought Sweden would become a nice place like California in 300 years' time if we keep on burning it. Actually, we've been burning fossil fuel much more than what was expected, especially after the Industrial Revolution, from steam engine to electric motor, gasoline engine, and then as the technology developed or need for energy increases, then we don't use the energy from wood. We need more than what sunshine have been giving us on the constant basis. So we started to dig the fossil fuel. Start with the coal, and then petroleum and natural gas. Although nuclear power started to contribute to a certain extent, but still very small. Hydroelectric power become available, but still a very small part. Most of the energy consumed was the fossil fuels. So that was the time we started to change our environment. And the change of the environment and change the society was quite astonishing. If you look at the Taiwan, the livelihood of Aboriginal tribe in the plain, like shown in the left-hand side of the slide, was a wedding party. By the bridegroom was carried in the carriage. And if you look at the picture here, all the things are made of natural product, bamboo, wood. But if you look at after the Industrial Revolution, lots of things are dug up from the ground and use the fossil fuel to process to make cement, make steel. And so this transformation was great. From natural product to everything, especially energy and product, came from underneath the earth and produced steel and aluminum and other things. Meanwhile, population increased. Last century when we started, we have 1.5 billion people. By the end of the last century, we went to 6 billion people. In that process, 1950, we said the Earth can support about 2.5 billion comfortably. Then went up and up. Then we said non-renewable resource will be depleted, and sustainable growth rate, worldwide environmental damage, and there are lots of migration of people will take place. Now, we are past 7.2 billion, 7.3 billion people, and we are reaching about 9.7 billion by the middle of the century, or 2050. The population really went up. What are the consequences? Of course, the consequences is Earth used to be an infinitely large place, like when in 1943, 43 when I was in the mountain. At that time, population are not so much, and we didn't consume very much. But now, with the population increases and consumes fossil fuel so much, we change the environment. So we are living on these thin layers, about 50 kilometer height of the atmosphere, hydrosphere. We are living here, but our human activity start to change the environment. So you can see, one thing you see is the pollution, air pollution. No matter where you go, you do see a scenery like this. But in 1962, I went to the States. It was interesting. There's a joke and said, a businessman from Los Angeles came to San Francisco, and he looked around, and he decided that he better go back to Los Angeles to buy another ticket when back to Los Angeles. People went ask him why. He said, I don't trust a place where I cannot see the air. At that time, Los Angeles, you can always see the smog. So he came to San Francisco, cannot see the air. So he started to become suspicious. This place might not have air. So flew back to Los Angeles. That businessman will become comfortable now. No matter where he go, he will see lots of smog, especially people concerned about PM 2.5. Well, the other thing is in the thin layer, we started to emit lots of carbon dioxide and other molecules which will cause the global warming. So you look at the sunshine, sun temperature is high, so emit most of the light in the visible region. We come to the Earth, reflected by cloud, reflected by Earth, absorbed by some atmosphere, and those amount, if those amount is the same as the emission from the Earth, Earth is usually cool, about 20 degrees centigrade. They emit infrared light. You cannot see, but the carbon dioxide, methane, and fluorocarbon will absorb the infrared effectively. So when the greenhouse gases increases, what you are seeing is more energy coming in than going out. So that's the problem we are having now. Sunshine gives us lots of energy. We are receiving more energy than we're putting out to the universe. And difference could be in every day more than 100,000 of atomic bomb, the size of the one who dropped in the Hiroshima, Nagasaki, like 100,000 of bombs bombing Earth every day, and Earth is accumulating lots of energy, lots and lots of energy, and that is going to cause lots of problems. So in the IPCC fifth assessment report said, if we keep on burning the fossil fuel and we do not do something, temperature will go up to more than 4.6, 4.7 plus minus 1 degree, and life will be miserable. And we do have an existential problem. Humanity might not exist by the time of the end of the century. So suggested we should bend the curve and try to reduce the emission of carbon dioxide to reach about 2 degrees centigrade from pre-industrial era. And that was the reason why 2 degrees centigrade was mentioned during the last 10 years. So 2 degrees centigrade. Actually, 2 degrees centigrade is really good temperature. If you look at the calamity you are facing and temperature rise, you see minus 0.61 is the pre-industrial era compared to the current time. And actually, its current time was in 2012. Actually, it's a little earlier than that. At that time, if you look at the color, white color means very good. Yellow starts to have some problems, become orange, become serious. The red color was become very bad and turned into purple. It's become impossible. Pre-industrial era, everything, unique straightening system, extreme weather events, distribution impact, global aggregate impacts all look good. But by the time 2003 or 2012, temperature already rise more than 0.6, it's almost 0.7. And when we said we should keep the temperature rise to within 2 degrees centigrade, will be here. That is really pretty bad. And I do not believe that the responsible scientists will accept 2 degrees centigrade as the goal. But why we say 2 degrees centigrade? Because we are not capable to keep the temperature rise within 3 degrees. So we said 2 degrees centigrade. But if you look at the current situation, temperature keep on rising. So temperatures rise to more than 1 degree now, 1.15 degrees centigrade, and people say 2 degrees centigrade is really, really bad because large-scale singular events which can turn things around. It's already in the orange color, so people say maybe 1.5 degree, but 1.5 degree, if you look at the color, are really pretty bad. So we always said the global warming is going to hurt the next generation. That's not quite so. Global warming is already here. 30 years ago, people talking about global warming, and 30 years, we didn't accomplish much. And it's really with us today. You came to Taiwan last week, you will see president and vice president were already in the southern part of Taiwan and apologizing that so much damage has been done by extreme precipitation. And look at Japan. Kansai Airport was closed. And that is happening all the time. And that was about 10 years ago. In 2008, I was elected to become the president of International Council of Science. And that was the year. One of the villages, Shaolin village, looked like this. Within 2 days, the precipitation is almost 2 meters of rain dropped in 2 days, and the entire village become that way, and more than 600 people killed. And the following year, those from Philippines, those scientists from Philippines must remember Typhoon Yolanda. Filipino people call it Typhoon Yolanda, go Haiyan. When it's landed, the speed is exceeding 100 kilometers per second and devastated the entire place. By 2015, that was the year I served for the president of the International Council of Science as the president-elect for 3 years, another 3 years as a president, another 1.5 years as the immediate past president, altogether 7.5 years. That year, I stepped down as the immediate past president. In September, UN passed the Sustainable Development Goal, 17 items, but at the end of the year, there's a COP21 in Paris. Politicians seem to be waking up. I've been giving many lectures in Taiwan, say it's time to wake up, time to wake up. I didn't wake up people very well. But 2015, many politicians got together in Paris and seemed to be awakened. And in the COP21, people got together and discussed the global warming trend because that is certainly a very important thing. And in the COP21, what was agreed upon is a non-binding global agreement to move toward the 2 degree centigrade limit, and ideally to a 1.5 degree centigrade limit. At that time, many countries made a commitment, non-binding commitment, but even those commitments are carried through. Temperature still will rise to 3.7 degrees, not 2 degrees, no 1.5 degrees. And the second thing is you have to spend $100 billion a year to help developing countries by 2020. This probably will not be a big problem because the global economic activity is 1,000 times as big as the $100 billion we're saying. Then next is to revisit carbon reduction plan in 2020. that certainly is going to change many things because there are more and more people are awakened. So I said, global warming is already here. Last year, when Typhoon Harvey hit Texas, and you look at the Houston, that's the picture you see in Houston. And if you look at the forest fire all over the world, 2 months ago, Sweden was burning. And then you look at the western coast of United States, 24 places were burning in state of Washington last week. California has the biggest forest fire in history. We keep on burning. And that's the picture of last week. We say global warming is here. And that's the picture took by satellite. And the color showing that in Asia, we always has the Asian smog. Those are mainly because of the agriculture burning. There's a lot of smog always floating in Asia. This is the forest fire in California. Smog showing is the red color. The bluish color was the aerosol came from typhoon. Typhoon will produce some aerosol, and those are the green color. And the white color, the dust came from big wind, like India. Usually you see all of those things. And this is August 23rd, last week. This picture taken last week by NASA. Global warming is already with us. I remember about a month ago, before I left for a global tour, I talked to the Vice President and said, government should accede to the fact global warming is here with us. We really start to change. We have to mitigate, we have to adapt. Otherwise, if extreme precipitation came and bring damage to Taiwan, you will be apologizing to the people again and again. That's not good. You take the leadership to cause change. I came back the day before yesterday. Before I came back, I sent an email to Vice President. He was here and said, see, that's what I said. Extreme precipitation will bring damage. Then you are coming out and say, apologizing. No matter how you apologize, it's not going to change. The things will get worse and worse. So you have to mitigate, you have to adapt, and we have to do lots of things in order to change this. But you see, the government, like the president and vice president, is getting lots of pressures. If you look at the, this is called free trade and globalization machine, and the one who are in charge is full speed ahead. Global GDP is going up, going up. Our industry will keep on pressure to our government and said, we need 5 things. We need electricity, we need water, we need land, we need cheap labor, we need to have outstanding science and technologies. We need 5 things in order to compete globally. But the people living here, we say, well, two things too much. One is the pollution, one is the greenhouse gases. So government could not try to satisfy the need of industry and said, I want to build a coal-fired power plant and I want to make sure that enough electricity. That will not assure their pollution and emission will go down. So there are lots of dilemma. We have to really take charge in changing it. So the young people are in a precarious position. She said, do something, you bunch of maniacs. I think 30 years from now, or 50 years from now, my great-granddaughter, grandson will say, how come my great-grandfather didn't do enough to let us be in such a bad situation? And the older people will say, well, it's easy to just criticize young lady And I suppose you've got an alternative all work out, have you? Historical eco-fanatic, always telling people how to do. Get yourself a proper job. We don't have much time left. If we keep on going, this ship will go down. We don't have much time left. And people will look at me and say, Professor Lee, you don't have much time left. You're 81 years old, so you don't have much time left. I said, that's true. I do not have much time left, but you do not have much time either. And this is an important thing. So in summary, I would say that politically, this is a global problem in need of global solutions. Carbon dioxide produced in the States and Europe, or Taiwan, or China, will spread all over the world. And unless we work together and solve it, rather than spend all the 2.4% of GDP on the national defense, buying weapons, airplanes, warships, but 30 years from now, people will realize our common enemy is really what we are doing. It's the global warming that will hit us very, very hard. And the second thing is, socially, we must turn away from the path of the overdeveloped societies. So when United Nations passed the Sustainable Development Goal in September of 2015, 17 items. It was not very easy because those 17 items of sustainable development is really modeled after the society developed in Europe, America. And we really turn away from the path of overdeveloped societies. So people often ask, we have to have enough energy. Then I ask, is 10 kilowatt enough? Or 2 kilowatt is enough? If you do not do anything, only need 100 watt to survive. And when you said Sustainable Development Goal, when we say we have enough clean energy for all, it's 2 kilowatt or 10 kilowatt. If everybody want to drive a car, like what America, Japan, European people are doing now, 10 kilowatt probably is the amount we need. Socially, we just said we from part of the overdeveloped society, we really have to come up with a model of how human society should develop. Technologically, we must learn to store, transform, and share energy from the sun. Sunshine gives us lots of energy just in 1 hour. The amount of energy gave to the earth is about the energy human society used for an entire year. We do receive lots of energy, but we have not learned to transform and store the energy yet. Well, maybe 50 years from now, young people from Taiwan say, Dad, I'm going to Australia to buy some sunshine. You might say, you buy sunshine? Say, yes. I go to Australia, I transform into electricity, and then I transform into some chemical, and I should be back home and to use it. So we learn to store or transform and share energy from the sun. Problem could be easily solved. But the next generation, we still need to take the carbon dioxide out from the atmosphere we have today. It's a challenging job and take lots of energy, lots of money. So we are living here. We continuously live on Earth. Earth is changing, Earth is changing, and we have to stop changing it for us, for the next generation, for the humanity. Human civilization might come to an end. After we went through 4.7 billion years after the formation of the Earth system, we might terminate the human civilization in just a short time of 1 century. And sun is shining all the time. And sun will keep on burning for another 4-5 billion years. But Earth will be there. Maybe 4-5 billion years around that time. Sun will keep on expanding, and engulf all the Earth. But that is 5 billion years from now. But within 100 years, we might see the disappearance of human civilization if we do not change. And this is really the most important thing in my mind. So I told you, when I went to the university, I had two things in mind. I wanted to be a good scientist. The second thing is I wanted to work with the idealistic people to make this world a better place to be. But I haven't accomplished that yet. Probably will not be able to do it. I'm gonna be gone before that happens. But everybody has the responsibility to work on it and it's serious. That's my master chef's cuisine, to cook up the future. I'll stop my lecture here. Thank you very much for your audience.
Thank you so much, Dr. Li Yuanze. Is it okay if we open the floor for some questions?
Sure.
Yeah, is there any question? If you have any question, feel free to raise your hand, and we do have staff members that will be handing you the microphone. Any questions? So people are still pondering. It's a really complicated questions and problems that we are facing, and science is the key. Yes.
Hello, thank you for a really moving and important talk. I'm Graham from the Australian National University. I wanted to ask what advice you give to young people today to be able to embark on, like as you pointed out with Marie Curie, an idealistic career and a career that really aims to change things, often when the society they live in is really fighting back. So what advice would you give to those young people?
In the concluding remark, they say the young people should learn to work with each other globally. I think the young people has the ability to make the global connection our generation didn't have. They can use iPhone to connect with each other and discuss the global problem. But the important thing is young people should realize that what we have been going through, so-called development, is really overdevelopment. We have to live a simpler life. I'm not talking about the life I led in 1943 to 45, but we have to go back to close to the nature and live a simpler life and use energy sparingly. And you have to change the attitude. And then, for those who want to be a scientist, we know we have big challenge ahead of us. That is to learn to store the solar energy or transform it. And that's the problem we have to face. When we have COP21, we still try to work with every country. Say, IMDC, every country come up with a proposal how to do it. I know places like Taiwan or many countries in Southeast Asia will not be able to accomplish that because population density, we have 650 per square kilometer, not like 5 in Australia. It's the difference. So we have to try to work together globally and understand what we mean by development in government. I always try to say we want to improve the economy, we want to find you a job. But what do we mean by improve the economy? Economy will not develop or stop completely if the global warming become worse or the carbon footprint become very large. So young people, it's a lot to think about. I'm not here to say you should not eat too well or you should skip school, stay home. And I will not have a single solution, but we have to change.
Wow, so, really thought-provocative. So, any other questions from the floor? Oh yeah, sure. So in the interest of time, this is going to be our last question, and thank you for the input.
Thank you so much, Professor, for the very enlightening.
Can we have another microphone?
But it's just a follow through from Graham's question about, and your response about technology of the generation now where they could easily connect with each other. But I have this nagging question right away because I'm in between generations, and I'm always wondering if this generation who were born to connect are connecting enough to the past to think what has come before them, that they treat this as normal and become content with this is what it is. So it's more of a wondering than a question, really. So how do you feel about that?
Well, it's a big dilemma. Because as a scientist, we attend the international meeting, and everybody talk about international collaboration. When you go home, then people ask you, or the government ask you, is that going to help national competitiveness? As a national competitiveness, competition in global collaboration is an entirely different thing. And when we talk about global warming, every country will do this, have to do this. And I often complain that unless we find a way to make the clean energy available in the global market, the global solution might not be easy to be found. So young people now make a global connection easily. So when I run like Asian Science Camp, 1 year is run by Israel. And the person asks every student to know that which group you are in. In the Asian Science Camp, we always divide the student into groups. But we let them know that you belong to group 7. There are how many group members you have, and try to contact them and try to know each other. And when they show up, the group members really communicate well, and they did know each other. So they came up there as they are good friends. So that's something we have not been able to do. And the students which come to the camp, which is really do not have to worry about the national boundary. But the real world is not true. Even if you go to different country, you have to have a visa, passport. Sometimes you'll be stopped. And competition and collaboration, we still have dilemma. So as I mentioned, globally we spend 2.4% of GDP on defense. Defense country being invaded by other country. When the European Union was established, they have one important conditions: the national boundary will not change, so there's no war. So now, if you cannot collaborate across the national border and use the 2.4% of defense budget on the global warming problem, we could solve the problem without any question. Not only we can stop the greenhouse gases to increase, we can even learn to take the carbon dioxide away from the atmosphere and store it. So who are the enemies? The neighboring country or the enemy we are creating ourselves become bigger and bigger. That's the global warming. So the next generation are facing something that we have not been able to accomplish. So we have to feel sorry for this. We have to apologize.
Thank you.
Thank you so much. Let's give biggest round of applause once again to Dr. Li远哲. And Dr. Li would like to join you for a group picture.